All right. So we're moving on. We are looking at alkanoic acid. Now, the general formula for alkanoic acid is CN, oh, wrong pen, H2N plus 1 COOH. Now, N is always one less carbon. N is always one less carbon because this first carbon in the functional group is 1. Right? So N is always one less carbon. So let's see how it goes. Let's see how this works. So it's CN, 2N plus 1 COOH. Here we have methanoic acid, right? And we're saying this is the first carbon. So it's COOH. So N is always one less carbon. So in this case where N is 1 and N is one less carbon, C 0. So if it's 0, we don't write C. 2 times 0 is equal to 0 plus 1, which is H. And also if we draw methanoic acid has 1 carbon. We're going to put on the functional group. So it's COH, and we're going to make sure that each carbon is bonded 4 times. This carbon is bonded once, twice, 3 times, and 4. So this is the acid, methanoic acid. If we draw ethanoic acid has 2 carbon. This carbon needs to be bonded 4 times. So if we look on the general formula is, we'll put back the COOH first. N is 2, but N here is always 1 less carbon. 1 less than 2 is 1. So it is C, and 2 times 1, 2 plus 1, 3. So this is how we get it. This is always the first carbon with the functional group, and the alkyl portion of it always have 1 less carbon. So this part is the alkyl portion. It always has 1 less carbon. Clear? So for the propanoic acid, this is the first carbon. N is 3, N is going to be 1 less carbon, so N is going to be 2, C2H5. If we draw propanoic acid, it's 3 carbon, we put on the functional group, which is the COOH, and then we add our H's. This is the COOH part, and the alkyl part, which is the C2 here, H5 is always 1 less carbon. Are we clear? So butanoic acid have 1 less carbon because of the functional group. So it's C3H7COOH. Pentanoic acid, we put the COOH, pent is 5, so we have 1 less carbon in the C. C4H9. COOH, we have 1 less carbon, so it's C5H11. Clear? So although we know the functional group, I did not write it. The functional group is COOH. Can be written like this, or we can call it carboxyl. All of them is the same thing. That's a functional group. Now, this is also polar. So this molecule is polar. 1, oxygen is more electronegative than carbon. And in the next case, oxygen is more negative than hydrogen, and we explained that this morning. So the acid is polar, right? And if they ask you which is more polar or which is more acidic compared to if they give you an alkanol or an acid, alkanoic acid, and the acetate, which is more acidic. The more acidic one is the alkanoic acid. It is more acidic because this molecule is way more polar than the OH alone. So the OH alone has this partial negative charge here, partial positive charge here. When we look at the COH, O is more electronegative than carbon, right? So it becomes H is more electronegative than oxygen. So this is slightly positive, slightly negative. Carbon is oxygen is more electronegative than carbon, so this becomes partially positive. Oxygen is more electronegative, so it's become partial positive. So in terms of the polarity, the one which is more polar, comparing the hydroxy to the carboxy, carboxy is more polar. Clear? All right, so now we're looking on reactions of alcohol. The first reaction we want to look on is esterification. In esterification, right? Esterification is the process of combining an organic acid, which is an alkanoic acid, with an alcohol or an alkanol in order to form an ester and water. The reaction is catalyzed by concentrated sulfuric acid. So in ester, it is a condensation reaction. What we're doing is, in order to form an ester, we must remove water. So esterification is a type of condensation reaction. Water is removed, and when we remove water, we are removing H and OH. Now, in order to remove, in esterification, the OH is removed from the acid and the H is removed from the hydroxy in the alkanol. So in order to form the water and the ester, we are going to remove the OH from the functional group of the acid, and we are going to remove the H from the functional group of the alkanol. So here I am putting the OH immediately beside. So when I draw my alkanol, I put my OH immediately beside my functional group from my acid. So I draw it like this. When I remove my water, I am going to be removing OH from the COOH from the acid. And then from the alkanol, I'm removing the H that is attached to the OH. So I am left with R, C double bond O, and then this bonds there, O, R, and water is formed. So we now have a new functional group, which is known as the ester, and this is the ester. The ester functional group is C double bond O. So anytime we see C double bond O, this is known as the ester functional group. Now, remember we said during esterification, so if we're doing the molecular equation, during esterification, the OH is removed from the COOH. So I'm going to be removing this. And it says that the H is removed from the hydroxy. Now, when I write it, I write the acid part first. And put O in front of the alkyl. So I write the acid part first. This is what is left from the acid. So I have C, I have RCO, and here what is left from the alcohol is an alkyl and an O, and it says I must write acid part and put the O in front of the alkyl group. So the alkyl group is being represented by a R here. So I'm going to switch it around and put the O R. This part comes from the alcohol or the alkanol, and this part comes from the acid. Clear? So let us say I have an acid, which is ethanoic acid, and I am forming an ester with methanol. I am removing the OH here from the acid. So I am left with R, not R, CH3CO, right? So the R is the CH part, right? And the H leaves here, so I'm going to put the O first, followed by the alkyl part, which is the CH. So it's CH3. So this part comes from the ethanoic acid, and this part comes from the methanol. Are we clear? All right, we're gonna do some examples, but first we're going to name esters. When we name esters, esters are called alkyl, alkanoic. And what we're saying is the alkyl comes from the number of carbon in the alkanoic acid and the number of carbon in the acid gives the alkanoid part. So here we have a reaction where we are reacting propanoic acid and ethanol. Propanoic acid reacts with ethanol in the presence of concentrated sulfuric acid and a little heat to form an ester. The alcohol has 2 carbons, so it's called ethanol. So the name of this ester is ethyl because ethyl comes from ethanol, and propanoic acid is the acid, so it's alkanoate, where this alk is prop, so it's going to be propanoate and water. So again, the ester has 2 parts. The part that comes from the alcohol comes first. So it's ethyl. Part that comes from the acid is next, propan. Here on the handouts, we have another ester, which is ethanoic acid and methanol. The alcohol has 1 carbon, so it's methyl. The alkanoate has 2 carbons, so it's methyl ethanoate and water that is formed. Mr. Bernard, what's the name of this ester? Mr. Bernard gone? I am never come back.
I'm here, miss.
Go ahead. Alkyl, alkanoate, where the first alkyl comes from the alcohol. So what's the alkyl name? No? Who wants to name the acid? Malia? Malia, where your friend then?
Because I don't know.
You don't know how to name the acid, or you don't know where your friend the ester, I don't know. What's the ester's name? Alkyl, comes from the alcohol. How many carbons in the alcohol, Malia? One. So it's ethyl.
Afternoon.
Good afternoon. Light, come back.
No data.
Oh, it work. They have ethyl. And then the other part is methanoic acid. So it's ethyl methanoate. Are we clear? We're going to go back through them anyway. Work on me. Ready? All right, so now we are going to draw the structures and do the molecular formula to form these esters that we have here. So let's go. We have propanoic acid, which is C2H. What's the formula for propanoic acid? We just wrote them down. Can we check?
C2H5CO.
So we have C2H5COOH, and we're reacting it with ethanol. What's the formula for ethanol? We did that this morning. So Malia, when I form the ester, what do I take from the acid functional group? In esterification, OH is removed from the COOH. So I should remove this OH right here. Then it says H is removed from the OH in the alkanol. I'm going to remove this right here. So what I have left is C2H5CO, and then I'm going to put the O in front of the alkyl. So it's O C2H5. And the name of this ester we say is alkyl propanoate. Clear?
Yes, miss.
Ready? All right, so now I'm going to draw it. So I'm going to draw propanoic acid. I'm gonna draw the acid and the alcohol up here, and then down the bottom I put the products because I won't have enough space. So propanoic acid has 3 carbons. I put on the functional group, and then I'm gonna make sure that each carbon is bonded 4 times. I'm going to draw my ethanol, but I'm putting the OH first. I am going to do my esterification reaction. Let me give you some time to draw this.
Yes, miss.
So during the esterification reaction, we are going to be removing our water. So I'm going to take my OH from here and my H from here, and then I will write back what is left. I'm gonna put the arrow here. What is left from my acid is this. And what is left from my alcohol is this. So again, in naming it, the number of carbons in the alcohol comes first. There are 2, so it's ethyl, followed by the number of carbons in the acid. So the number of carbons in the acid is 3, so it's propanoate. And my water forms. Clear? All right, ready? So ethanoic acid, we will start by doing the molecular formula. So the acid, ethanoic acid is CH3COOH. Remember, this is 1 carbon, this is another carbon, so it's 2. It's reacting with methanol, sorry, which is CH3OH. From the acid, I'm going to remove this, and I'm going to remove this H. So from the acid, I have left CH3CO. From the alcohol, I have OCH3, so I put the O in front of the CH3, and I also have water forming, which is H2O. So from the acid, we are going to take out the OH and the H from the alcohol. So we are left with, from the acid, and then from the alcohol, number of carbon in the acid is 1, so it's methyl. Number of carbons in the acid is S, so it's ethanol. it. And of course, water, which is H2O, is formed